to the countdown.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. Yang dihormati para guru, ibu bapa dan pelajar-pelajar sekalian, selamat datang ke Pusat Tuisyen Academy YouTuber dengan usaha-sama e-didik Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Sebelum kita mulakan kelas, eloklah kiranya kita membaca umul kitab bagi yang Muslim dan bagi yang bukan Muslim berdoa menurut kefahaman masing-masing. Al-Fatihah. Apa khabar pelajar-pelajar sekalian? Harap semuanya berada dalam keadaan sihat dan bersedia untuk meneruskan kelas kita pada hari ini. Cikgu percaya para pelajar sudah tidak sabar untuk meneruskan kelas kita pada kali ini. Cikgu perkenalkan diri dahulu. Nama saya Cikgu Shahnon dari KMPP selaku moderator pada petang ini. Kelas kimia kita pada petang ini bertajuk gas. Pendek saja, gas. Yang akan disampaikan oleh Teacher Tang dari Kolej Matrikulasi Selangor. Pada petang ini, kita bersiaran secara langsung dari channel beliau. Kepada yang belum subscribe, silalah tekan butang subscribe sebagai tanda sokongan. Bersama-sama kita juga di atas konti ini adalah Cikgu Mau. Tidak dilupakan Teacher Kong dari Kolej Matrikulasi Perak yang berperanan sebagai pegawai pemerhati. Baiklah, sebelum kita teruskan kelas kita, ingin cikgu ingatkan semua pelajar dan penonton yang ingin menghantar komen supaya menggunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk tontonan umum. Cikgu percaya semua yang hadir pada kelas petang ini merupakan pelajar-pelajar yang cemerlang dan mari kita menunjukkan disiplin yang terbaik. Sila fokus pada isi pelajaran yang akan disampaikan. InsyaAllah, moga kelas kita pada petang ini dapat dimanfaatkan sepenuhnya oleh semua. Untuk makluman, link sijil akan diberikan di akhir siaran. Sila gunakan email e-didik, MOE, MyGuru dan Jawi sahaja. Dan sila ambil perhatian, link ini akan tamat selepas setengah jam sesi live ini berakhir. Baiklah. Seterusnya khas untuk para pelajar sekalian, cikgu akan umumkan paskod bagi kredit AYU. Cikgu akan bagi 3 sesi untuk paskod ini. Inilah sesi yang pertama. Paskod yang pertama ialah A dan nombor 1. Cikgu ulang. A, abjad A dan nombor 1. Jadi tanpa membuang masa lagi, mari kita persilakan Teacher Tang dengan tajuknya gas. Teacher Tang on mic. Please on mic. On mic.
Sorry about that. Okay. So thank you, Cikgu Shannon. So I'm Teacher Tang from Kolej Matrikulasi Selangor. So I have around 8 years of experience teaching chemistry. So this is the pre-U chemistry team. So all of us led by Cikgu Shannon. So among us, we have Teacher Boyce Law, me, Cikgu Shannon, Cikgu Mawa, and Teacher Kong. So beside chemistry pre-U team, we have the mathematics pre-U team led by teacher In, and biology pre-U team led by Cikgu Faiza, and also the physics pre-U team led by Cikgu Rosmaya, and also the accounts and economics team led by Madam Fizi. So now we move on to our topic for today. So that is gas. So for matriculations, chemistry, this is chapter 5, states of matter, 5.1, gas. So these are the learning outcomes that I'm I will start with the basic assumptions of kinetic molecular theory of gases for an ideal gas. So basically, for kinetic molecular theory of gases for an ideal gas, so there are a few assumptions that are being made. So the first one, we assume that the gas molecules are in continuous random motions. So means that they move around constantly with no particular direction because the motions is random. And when they move, when the gas molecules move, they will frequently collide with each other and also with the wall of the container. When collide with the wall of the container, it will collide with a force and then exert a force per unit area on the wall of the container, result in the pressure being exerted at the wall of the container. So this is the first assumptions that we made under kinetic molecular theory of gases for an ideal gas. So the gas molecules are in continuous random motion. So the second assumption is we assume that the collisions between the gas molecules are perfectly elastic. So perfectly elastic collisions means that during the collisions, there will be no loss in kinetic energy, and the kinetic energy before and after the collisions will stay the same, and the total energy of the system remains constant. And the third assumption, we assume that the volume of gas is negligible compared to the volume of container. So the volume here basically is referring to the volume for the gas to move freely. For an ideal gas, so ideal gas, basically the size of ideal gas is very small. So it's like a dot like this. So the size is very small. So when this ideal gas occupying a volume, basically the volume of the ideal gas, we can say to be able to neglect them because they are very small. So we can neglect the volume of the gas compared to the volume of container. Therefore, for an ideal gas, so the volume for the gas to move freely is equal to the volume of container due to the size of the gas particle being very small in an ideal gas. So, and the fourth assumption is we assume that in an ideal gas, there is no intermolecular forces between the gas molecule. So we assume no intermolecular forces between the gas molecule because the gas particles, they are very far apart. Okay, that is assumptions that we make in an ideal gas. And the fifth assumption is we assume that the average kinetic energy, so average kinetic energy is directly proportional to its absolute temperature. So absolute temperature here refer to temperature in Kelvin. So based on these five assumptions for gases of an ideal gas, so basically there are a few parameters that we can study about a gas. So the first one is the volume. Okay, so the volume. And the second one is the absolute temperature. And the fourth one is pressure. The third one is the pressure. And the fourth one is amount of gas. Okay, amount of gas. So there are four parameters which we can study about a gas. Then now we move on to look at gas law. The first gas law is Boyce Law. So basically, of the 4 parameter in Boyce Law, so Boyce studied about parameter between volume of gas and the pressure of gas. So Boyce found out that the volume of gas is inversely proportional to its pressure. Means that as the volume of gas increases, the pressure of the gas will decrease. Okay, provided another 2 variable, the absolute temperature and also the amount of gas must stay constant. So 4 variable, right? So volume, pressure, absolute temperature, and amount of gas. So Boyce Law study about volume and pressure. So another 2 variables must be made constant. Okay. So and in Boyce Law found out that the volume of gas is inversely proportional to its pressure, provided the amount and the absolute temperature of the gas are remain constant. So based on this relationship, we then can write mathematical equation. So V equals to constant 1 over pressure. Okay, and then we can rewrite the equations to give us PV equals to K. So PV equal to a constant. So means that pressure of a gas multiplied with its volume will give us a constant. Therefore, we come up with the first mathematical equations related to gas, which is P1 V1 equals to P2 V2, because the pressure multiplied with the volume will give us a constant. So therefore, P2 multiplied by V2 also will give us a constant. So this is the first mathematical equation that we can use in calculations related to gas. So again, Boyce Law. So in Boyce Law, we know that the volume of gas is inversely proportional to its pressure. So when we sketch the graph, so this shows the inverse proportional relationship between the volume of gas and its pressure. But if we plot it volume versus 1 over P, then we will get a directly proportional graph passing through the origins. Okay, and then PV is equal to a constant. Therefore, if we sketch a graph of PV multiplied with P, it will be a constant graph. So it's a straight line graph passing through a constant. So this is Boyce Law. So the second gas law is Charles Law. So Charles Law basically study or investigating relationship between the volume of gas and its absolute temperature. Okay, according to Charles Law, the volume of gas is directly proportional to its absolute temperature. Therefore, if we plot a graph of volume of gas versus absolute temperature, we will get a directly proportional graph passing through the origin. Okay, of course, provided another 2 variable, pressure and the amount of gas must remain constant. So this is the relationship that we can write based on the Charles Law definition. So volume of gas is directly proportional to its absolute temperature. And then mathematically, we can write volume of gas is equal to constant multiplied by absolute temperature. And rearrange the equation, we get VT over K. So means that volume of a gas divided by its absolute temperature is equal to a constant. Therefore, come the second mathematical equation that related to gas. Okay, because V1 divided by T1 will give us a constant, so as V2 divided by T2 will also give us a constant. Okay, so therefore we get the second mathematical equation related to the gas. So, and must remember in the Charles Law, okay, it is written the relationship between the volume of gas is directly proportional to its absolute temperature in Kelvin. But if we are plotting a graph, volume versus temperature in degrees Celsius, we will actually get a increasing linearly graph like this. Okay, and then when we extrapolate to V equals to 0, we will get the temperature. So it will, when we extrapolate to V equals to 0, we we will see that it will cut through the temperature at negative 273.15 degrees Celsius. So basically, this negative 273.15 degrees Celsius is absolute zero temperature, which is equal to 0 Kelvin. Okay, so 0 Kelvin equals to negative 273.15 degrees Celsius. Therefore, if whatever temperature in degrees Celsius, so whatever temperature in degrees Celsius, we want to convert to Kelvin, we must add 273.15 in order to convert the temperature from degrees Celsius to Kelvin. So combining Boyce Law and Charles' Law, so we will get this. Okay, so we get volume of gas is directly proportional to its absolute temperature, but inversely proportional to its pressure. So mathematically, we can rewrite this equation to V equals to K Tp. And then we write this equation, we get PV divided by T equals to a constant. Okay, so therefore comes the third mathematical equation related to gas. Okay, so P1 V1 divided by T1 equals to a constant, which is equal to P2 multiplied by V2 divided by T2, which is also equal to a constant, to the same constant actually. So then we comes to the third gas law, so Avogadro's law. So Avogadro's law, we study about the relationship between volume and also the moles of gas present. So in Avogadro's law, basically it defined that the volume of gas is directly proportional to the amount of gas present, provided the temperature and also the pressure of the gas is remain constant. Okay, so this is the relationship underlined by Avogadro's law. Volume of gas is directly proportional to the number of moles of gas present. Okay, provided the absolute temperature and pressure are constant. And mathematically, we can write the relationship as V equals to Kn. Okay, and then from there we can rearrange V divided by N is equal to a constant. Therefore, comes to the fourth mathematical equation related to gas, which is V1 divided by N1, giving us a constant, which is equal to V2 divided by N2, which is equal to the same constant. So if we sketch a graph of volume of gas versus amount of gas, we will get directly proportional graph, so passing through the origin. So, and then in this 5.1 gas, you also learn about ideal gas equation. So how to derive ideal gas equation? Basically is combining the three gas law. So when we combine the three gas law, Boyce Law, Charles' Law, and Avogadro's law, we will get that the volume of gas is directly proportional to the amount of gas and its absolute temperature, but inversely proportional to its pressure. Okay, so mathematically, we can rewrite the equation. So volume of gas is equal to a constant, NT divided by P. And then we can rewrite this equation to give us PV equals to nRT. And this R is a constant and having its own name. We call this as ideal gas constant. And in this chapter, so the value that we are going to use, the value of R, ideal gas constant that we are going to use is 0.08206 liter per mole per Kelvin. Okay, therefore, because we are using the ideal gas constant R, 0.08206 liter atm per mole per Kelvin, therefore, when we use ideal gas equations in calculation, we must make sure that the pressure that we use is in atm, volume is in liter, and then number of moles must be mole, and the absolute temperature must be in Kelvin. Okay, due to the R value, the constant value that we are going to use is 0.08206 liter atm per mole per Kelvin. So must remember this. Okay, when you use ideal gas equation, pressure must be in atm, volume in liter, and the absolute temperature in Kelvin. So, and then from the ideal gas equation, we can also derive molar mass for a volatile liquid or a gas. Okay, so in ideal gas equation, we know that this is N is number of moles. And basically, N number of moles we can calculate by dividing mass with molar mass. Okay, so therefore, if we substitute mass divided by molar mass into the number of moles in ideal gas equation, we get this equation. Okay, so this is equal to number of moles. And then we rewrite this equation in terms of molar mass. Then we get mass multiplied by RT divided by PV equal to the molar mass of a gas or a volatile liquid. Okay, so must remember this formula we derive from ideal gas equation. Therefore, if we want to use this formula, must make sure the pressure must be in atm, volume in liter, absolute temperature in Kelvin, and also the mass of a gas in gram. Okay, because the ideal gas constant that we are going to use is 0.08206 atm liter per mole per Kelvin. So beside molar mass, we can also derive density from ideal gas equation. Okay, so we know that this number of moles here we can calculate by substituting mass with mass divided with molar mass. So we just substitute mass divided by molar mass into the number of moles in ideal gas equation. We get this equation. Okay, and we know that density is equal to the mass of a volume. So we just need to rewrite this equation in terms of mass over volume. So this is equal to density. So we can then get the density equation, okay, to calculate the density of gas or volatile liquid using ideal gas equation. So density is equal to mass over volume, which is also equal to pressure multiplied by the molar mass divided with ideal gas constant multiplied by absolute temperature. So this is the formula for density that we derive for density of a gas or volatile liquid that we derive from ideal gas equation. Again, when we use this formula, must make sure that the pressure is in atm, molar mass is in gram per mole, and then the absolute temperature in Kelvin, because we derive this equation from ideal gas equation, and the R here, ideal gas constant, is 0.08206 atm liter per mole per Kelvin. So basically, these are a few formula that we derive from the Boyce Law, Charles Law, Avogadro's law, and also ideal gas equation. Okay, so you need to remember this formula because formula will not be given in exam. Okay, so you need to remember the formula. So now I want to move on to teach you how to do problem solving related to the gas. Okay, so to do the problem solving, basically first you need to list out the information that is being given in the question. Okay, and then from the formula list, so these are the formula, you choose an appropriate formula that related to this information. And then in step number 3, you just need to substitute the information into the formula to get the final answer. So shall we look at question 1? So question 1, so step number 1, first we must highlight the information that are being given in the question. Like for example, in this question, we are being given pressure. So we know this is pressure. So you can label it as P first. And temperature, 25 degrees Celsius. So for this chapter, okay, so for this chapter, must remember all are absolute temperature. So whenever you see temperature, just need to remember to convert it to Kelvin. So like for this one, is 25 degrees Celsius, you can convert it to Kelvin. So how to convert it to Kelvin? Just adding 273.15. So you get 298.15 Kelvin. Okay, so it is this is still step number 1. So and then continue reading the question. So we are being given volume, and then we are being given another pressure. So this is the first pressure, so we label it as P1. So this is P2, and this is the volume related to P2, so therefore label it as P2. And the question say temperature stay the same, okay, stay the same, okay, and ask you to determine the original volume of the gas. So means that you want to find V1. So this is step number 1. You list out all the information that are being given to you first, okay, and then in step number 2, you need to choose an appropriate formula based on what you have listed out in step number 1. So very clear that for this question, okay, we need to use this formula, okay, because we have P1, V1 we want to find, and then we have P2, and then we have V2. Okay, so therefore, step number 2, very clear that we need to use this formula. So now, what I want you to do is, I want you to calculate what is the answer for question number 1. So I give you 30 seconds. Any answer from the students?
Not yet.
Not yet. Okay, so students, you just need to substitute. So P1 is here, 4.27 atm. V1 you want to find. So this is step number 3. We want to substitute all the information into the formula. So P2 is 1.63 atm. V2 is 10.5 liter. So you just need to calculate what is your V1. So any answer from the students?
Not yet.
Not yet. Okay, so I cannot wait. Okay, so the answer is A. So you should get 4.008 liter. Okay, so we move on to look at question number 2. So question number 2, also the same. So we just need to follow through the 3 steps. Okay, follow through the 3 steps. Step number 1, you list out all the information that are being given to you. Okay, and step number 2, you choose an appropriate formula. And step number 3, you substitute to get the final answer. So shall we look at question number 2? So we are being given, okay, so this is temperature. Must remember 5.1, it is absolute temperature. So must convert it to Kelvin. Okay, so this should give us 753.15 Kelvin. So this is still step number 1. And then what else been given to us? We have been given pressure. Ask us to calculate volume. So ask us to calculate volume. Okay, and then we have been given volume. So this must be, so this is the first volume. So this must be the second volume. Okay, and we have been given pressure again. So means that this must be the second pressure because related to V2. So means that the previous pressure is a P1. Okay, and we have been given temperature again. So this temperature is related to V2, therefore it is T2. And the previous one is T1. So again, for this 5.1, the temperature is referring to absolute temperature. So must convert to Kelvin. Okay, so this is step 1. We list out all the informations that are being given to us. And then step number 2, we choose an appropriate formula. So from the informations that we listed out, we can see that the most appropriate formula is this one. Okay, then step number 3, we just need to substitute into the formula to get the final answer. So P1 is 12.8 atm. B1 we want to find. T1 is 753.15 Kelvin. And then P2 is 1 atm. B2 is 1.8 times 10 to the power of 3 liter. And T2 is 295.15 Kelvin. So then we can calculate what is our V1. So I give you again 10 seconds. Calculate what is your V1.
Yeah, 10 seconds. After that, we have a tea break.
Oh, okay.
10 seconds.
10 seconds. Any answer from the students?
They are still calculating.
They are still calculating. Okay, then maybe we can go for advertisements first, and then I will review the answer after that.
Yeah, that's good.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Ya, itu
Okey,
sebelum kita menunggu jawapan daripada pelajar, saya nak umumkan paskut kredit AYU yang kedua, iaitu nombor 1 dan nombor 1. Ulang lagi sekali, nombor 1, lepas tu nombor 1 lagi. Itulah paskut yang kedua. Dan kita ada paskut yang ketiga last kali nanti. Okey, silakan Teacher Tang.
Okay, so the answer should be 358.8 liter. Okay, so we can move on to look at question number 3. So in this question, the question asks, okay, so step number 1. Okay, we list out all the informations that are being given in the question. Okay, so the question, okay, so just now, okay, so temperature, so this is T1. So is 753.15 Kelvin. So pressure P1, 12.8 atm. So and then this question asks us to calculate the mass of gas transfer. Okay, and then this is the volume. So we know this is a V2. So this is the P2. So this is the T2. So 295.15 Kelvin. Okay, so based on the informations that we have, okay, so the questions want us to calculate the mass of gas transfer. So instead number 2, we need to choose appropriate formula. So the most appropriate formula which involve mass will be this one. Okay, so and then what we need to do instead number 3, we just need to substitute the information that we have into the formula to calculate the final answer. Okay, so how to do that? Okay, so pressure 1 atm, volume 1.8 times 10 to the power of 3 liter. remember, number of moles is mass over molar mass. So molar mass here is 16 gram per mole. And the R here is 0.08206 atm liter per mole per Kelvin. And the absolute temperature here is 295.15 Kelvin. Okay, so then we can calculate the mass of the gas. So again, I give you 10 seconds to calculate the mass of the gas. Any answer from the students?
X Zippo A.
A. The answer is C. Okay, so you just need to substitute and then you will get the answer C. Okay. Okay. So shall we continue? So question number 4 again. Okay, so before start the calculation, so must list out all the informations that are being given to you first. Okay, so we have been given temperature. So must remember in 5.1 is referring to absolute temperature. So must convert it to Kelvin. Okay, so we should get 298.15 Kelvin. Okay, and this is volume, and this is mass, and this is pressure. So we want to calculate the molar mass of the gas. So this is step number 1. Okay, these are all the informations that are being given to you. Step number 2, you must choose an appropriate formula. So we can see that this is the most appropriate formula. Okay, so and in step number 3, we just need to substitute all the information into the formula to find the molar mass of the gas. Okay, so 0.3 gram, so 0.08206 atm liter per mole per Kelvin, and the absolute temperature 298.15 Kelvin, and then pressure 0.757 atm, volume is 0.22 liter. Okay, so calculate what is the molar mass of this gas. So again, I give you 10 seconds. Try this. Okay, hello students. So try. Okay, Shabani, you can try question number 4. And Zippo as well, you can try question number 4. See what answer do you get. I give you 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Any answer from the students?
Misha Hani C.
Okay, so very good. The answer is C, cat.
Z Chai C, also C.
Oh, very good. Okay. So now we move on to look at question number 5. So again, follow through the 3 steps. So step number 1, we list out all the information that are being given to us. So 5.1, remember, temperature must be in Kelvin. It's referring to absolute temperature. So convert it to Kelvin. So this is volume. This is mass. So this is pressure. So the question 1, density. So now we just need to, so this is step number 1. We list out all the information that are given to us. So step number 2, we choose the most appropriate formula to solve this question. So density. So this must be the most appropriate formula. So step number 3, we just need to substitute into the equation. So mass 0.3. Volume 0.22 liter. So what is the density of this gas? So again, I give you 10 seconds. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so any answer from the students?
Only answer question 4, not
Huh?
question 5 yet.
Okay, not yet question 5. Okay, yeah,
Still
students?
waiting for answer question number 5.
Okay, so what is your answer for question number 5? Any answer?
Norliana Patini, A.
Okay, A, very good. Okay, so this is
Also A.
okay, very good. Okay, so this is the answer for question number 5. Just need to remember this chapter not very difficult. Okay, so just need to follow through the 3 steps. You list out all the information, you choose the most appropriate formula, substitute, then you can get the answer. Okay, so then we can move on to look at Dalton's law of partial pressure. So according to Dalton's law of partial pressure, the total pressure of a mixture of non-reacting gases is equal to the sum of their partial pressure exerted by each gas in the mixture. So for example, gas A in 2-liter container exerting partial pressure of PA on the container. So gas B in 2-liter container exerting partial pressure PB on the container. Gas C in 2-liter container exerting partial pressure PC on the container. When these 3 gases, A, B, and C, they are non-reacting gases, means that do not react with one another. All these 3 gases being put into a 2-liter container. So the total pressure, according to Dalton's law, is equal to the sum of the partial pressure of each of these gas. Okay, so that is what meant by Dalton's law of partial pressure. So, and then what is the relationship between the partial pressure and number of moles according to Dalton's law? So, for example, gas A in a volume B exerting partial pressure PA on the container, gas B in the container with volume V as well, exerting partial pressure PB on the container. So when we put gas A and gas B together in a container also having the volume V, according to Dalton's law of partial pressure, the total pressure will be equal to the sum of the partial pressure of the gases in the mixture. Okay, so this is according to Dalton's law. So then how can we calculate the partial pressure of gas A? So to calculate the partial pressure of gas A, we need to assume that the gas A is an ideal gas. So when we assume that it is an ideal gas, then we can use ideal gas equation to calculate the partial pressure for gas A. So ideal gas equation is very specific. So if this is for gas A, then this is the partial pressure of gas A, and this is referring to the number of moles of gas A. So to calculate partial pressure of gas A, we can rewrite the ideal gas equation to give us number of moles of A multiplied by RT divided by V. To calculate partial pressure for gas B, also the same, we can assume that the gas B is an ideal gas. So to calculate the partial pressure of gas B, we can use ideal gas equation. So I told you before, ideal gas is very specific. So if it is for gas B, then this is referring to the partial pressure of gas B, and this is referring to the number of moles of gas B. To find partial pressure of gas B, we write the equation, give us number of moles of gas B multiplied by RT divided by V. Okay, and then, okay, so if we are having total gas, mixture of gas, okay, so we can also assume that this mixture of gas, they are ideal gas. So we can use ideal gas equation to calculate the total pressure. Okay, but then must be careful when, okay, ideal gas equation I told you already is very specific. So if it is referring to total pressure, then the number of moles here must also refer to the total number of moles of gas. Okay, so to find total pressure, we just need to rewrite the equation to give us total moles of gas multiplied by RT divided by V. Okay, so according to Dalton's law of partial pressure, total pressure is equal to the sum of partial pressure of the individual gases in the mixture. So total pressure, we know that to calculate it, we can use this term. So NT multiplied by RT divided by V. So, and then to calculate the partial pressure of A, we can calculate using this. NaRTB, and then to calculate the partial pressure of gas B, we can use this term. So substitute in. So RO can cancel out. Absolute temperature are the same. Volume also the same. Therefore, we get another equation that related to Dalton's law, whereby the total moles of gas, the total moles of the gas mixture is equal to the sum of the number of moles of individual gases in the mixture. And then if we want to find the fraction of gas A in the mixture, for example, we want to find the fractions of gas A in the mixture. So how can we find the fractions of gas A in the mixture? So basically you apply the same mathematical concept. So if I ask you, how do you find the fractions of female students in your class? So definitely you will tell me that it is equal to the number of female students divided by the total number of students in the class. So as if we want to find the fraction moles of gas A, it is equal to the number of moles of gas A divided by the total number of moles of gas in the mixture. Besides, using this, we can also calculate using the partial pressure and also the total pressure. So to calculate the fraction of mole fractions of gas A, basically it is also equal to the partial pressure of gas A divided by the total pressure. Okay, so with this, then we can see that we get another field formula that related to Dalton's law. Okay, so these are a few formula that is related to Dalton's law that we derived just now. So how do we solve the problems, calculations problems related to Dalton's law? So basically, so 3 steps to follow through as well. So step number 1, still the same. We list out all the information that is being given to us, but now we need to determine whether the question is related to Dalton's law or not. Okay, so how do we know whether it is related to Dalton's law? So basically, you need to read the question. If it involves mixture of non-reacting gases, then definitely it is referring to Dalton's law. Okay, and then step number 2, we just need to choose an appropriate formula that is related to Dalton's law. So among these 5 formula, you choose one. Okay, and then you substitute into the formula to get the final answer. So for example, this question. So how to do this question? So this question, okay, we are being given 82% ethane gas, 18% ethane gas. So total sample, so this is total mass. So it's 15.5 gram. And this is the volume of the gas. And the temperature here, remember, must convert to Kelvin. Okay, so that will be 293.15 Kelvin. Okay, so, and the question asks us to calculate the partial pressure of ethane gas. Okay, so these are step number 1. We list out all the informations that are being given to us. and then confirm that this is related to Dalton's law. How do I know that this is related to Dalton's law? You see, mixture of gas. Okay, mixture of gas. So definitely it's related to Dalton's law. So in step number 2, we want to choose an appropriate formula to solve this question. So the question 1, partial pressure of ethane gas. So can you see that this is the most appropriate formula that we can use to solve this question? Okay, so the PA here is the partial pressure of ethane gas. So to find the partial pressure of ethane gas, we need to have the number of moles of ethane gas, and also total number of moles of gas, and also total pressure. So how do we find the number of moles of ethane gas? So we know that it is 18% in the gas mixture. So 18%. So how do we calculate the mass? Okay, so basically, so 18%, so means that is 18 over 100. The total mass here is 15.5 grams. So we just 18 over 100 multiplied by 15.5, we get this is the mass of ethane gas. Okay, remember to use the formula, we need to find the number of moles of ethane gas. So we just need to use the mass divided by molar mass, then we get the moles of ethane gas. And then we also need to find the total number of moles. To find the total number of moles, remember, we have moles of ethane gas. We also need to have the moles of methane gas. So how do we find the moles of methane gas? So methane gas, 82%. So 82 over 100 multiplied by the total mass. So this is the mass of methane gas. So, and then mass divided by molar mass. So we get the moles of methane gas. So we just need to sum the 2 moles to get the total moles of the gas. And then we also need to have the total pressure. So how do we find the total pressure? So basically we can apply this formula because we have total number of mole. We apply this formula, then we get total pressure. Okay, and then in step number 3, we just need to substitute the moles of ethane, total mole, and total pressure into the formula. Then we get the partial pressure of ethane gas as 0.1491 atm. Okay, so then now we move on to look at question number 7. So how to do question number 7? So again, so for this question, first we need to list out all the informations that are being given to us. Okay, so for hydrogen gas, we have number of moles. Okay, we have volume. Okay, and for carbon dioxide gas, we also have number of mole. Okay, and we also have the volume. Okay, so now we read the question. So ignoring the volume taken by the valve, calculate the partial pressure of each gas. So we want the partial pressure of each gas. And the final pressure of the mixture. Okay, so the gas are allowed to mix. The gas are allowed to mix. So means that at the end, the final volume is not 1 but 4 liter, not 3 but 4 liter for both gas. Okay, because they are allowed to mix. So therefore, I should write this. So the volume at the end is 4 liter. Okay, at the end is 4 liter. Okay, so and given the temperature, remember, convert to absolute temperature. Okay, so this is the temperature. So this is step number 1. We list out all the informations that are being given to us. And then instead number 2, we need to find which one is the most appropriate formula to calculate the partial pressure of each gas. So among this, so can you see that this is the most appropriate formula? So to find the partial pressure of hydrogen gas, we can use this formula. So partial pressure of hydrogen gas equal to number of moles of hydrogen gas, RT divided by V. So number of moles of hydrogen gas, so 0.5 mole. R here is 0.08206 atm, liter per mole per Kelvin. And the absolute temperature here is 298.15 Kelvin. And then because this question says the gas are allowed to mix, so at the end, when they mix, the volume is 4 liter. So therefore, need to divide by 4 liter, then we get the partial pressure for hydrogen gas. So I give you 10 seconds. 10 seconds. Okay, tell me what is your answer for partial pressure for hydrogen gas. 9, 8, 7, 6, 5, 4, 3, 2, 1. Any answer from the students?
Not yet.
Not yet.
Because maybe because we have a lag between Vinyard and YouTube, maybe.
Okay.
About 5 seconds.
Okay. Any answer from the students?
Not yet.
Yeah.
Yeah. Nurliana Fatini.
Okay. So what's the answer?
3.05.
Okay, good. So this is the partial pressure for hydrogen gas. So how about the partial pressure of carbon dioxide gas? So also the same thing, you also apply this formula. So equals to carbon dioxide mole. So the number of mole is 0.25. R is 0.08206 atm, liter per mole per Kelvin. And then absolute temperature 298.15 Kelvin. And the volume at the end after mixing is 4 liter. So any answer from the students about the partial pressure for carbon dioxide gas? So student, I give you 10 seconds, calculate. What is your answer for partial pressure for carbon dioxide gas? Any answer?
Not yet.
Not yet. Okay. Any answer?
Still waiting.
Okay, so the answer should be 1.529 atm. Okay, so how to calculate the final pressure? So the final pressure here is referring to total pressure. So for this one, we can apply Dalton's law. So we can apply this formula. To find the total pressure, we just need to sum the partial pressure of hydrogen gas and carbon dioxide gas to get the total pressure equal to 4.587 atm. Okay. So do they get the answer? Okay. So it's about the time, right? So I think I stop here. So I stopped at Dalton's law of partial pressure. A little bit more left actually on ideal gas behavior and non-ideal gas behavior. But since it's already 4:30, then I stop here. Okay, so that's it from me today. Thank you everyone.
Okey, baiklah para pelajar sekalian. Sekian tadi kelas kita pada hari ini, iaitu gas yang telah disampaikan oleh Teacher Tang. Okay. Tahniah ucapkan kepada semua yang setia bersama hingga akhir, daripada mula hingga akhir kelas kita pada hari ini. Kini tiba pula untuk diumumkan kelas passcode kredit AYU yang terakhir, iaitu nombornya ialah nombor 5 dan nombor 8. Diulang, nombor 5 dan nombor 8. Jadi bolehlah kumpul ke semua kod daripada passcode daripada yang pertama, kedua dan ketiga tadi untuk menuntut ada hadiah lah. Tapi kena banyak lah kredit dia. Alright. Sebelum kita tamatkan sesi secara langsung pada hari ini, mohon tutup dengan chat dan klik butang subscribe kepada yang mereka yang belum subscribe channel Teacher Tang, okay? Supaya kita tidak terlepas sesi kelas yang seterusnya. Sekiranya sesi ini bermanfaat, silalah klik butang like dan share kepada rakan-rakan yang lain, kerana kami akan bersiaran setiap minggu 3.30 minit petang hingga 4.30 minit petang untuk topik-topik ataupun subtopik yang lain pula. Sila type down pada ruangan komen sebelum link sijil akan diberikan sebagai tanda terima kasih daripada cikgu dan kamu yang minta ikhlas pada hari ini. Adakah link sijil telah diletakkan pada ruangan komen? Silakan pegawai teknikal kita untuk meletakkan link sijil pada hari ini. Yang mana link sijil ini boleh diakses dengan menggunakan akaun IDD, MURID, Jawi dan lain sebagainya. Ya, nampaknya telah pun diletakkan. Sijil telah pun diletakkan. Jadi itu saja untuk kali ini. Okay. Terima kasih lagi sekali diucapkan kepada Teacher Tang atas penyediaan pelajaran pada hari ini. Terima kasih juga kepada Teacher Kong, Ibu Bapa yang bersama-sama kita pada hari ini. Okey. Akhir kata, terimalah serangkap pantun. Di atas dahan melihat rusa tepi pergi. Salam perpisahan untuk semua. Di lain masa bersama lagi. Sekian. Assalamualaikum warahmatullahi wabarakatuh. Jumpa lagi di minggu hadapan.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.